right, hi everyone. My name is Alice. I'm a host of House of ZK Radio. I'm here today with Lukas from Taceo. So thank you so much for being here today, Lukas. I'm very excited to have you during Noircon.
Thank you for having me.
Yeah, thank you.
Great to be here.
And I'm wondering if we can first start off with an introduction of yourself. So first, how you got involved in the ZK spaces and what led you to found Taceo?
Yeah. So my journey started as a mathematician. I studied math and then later came into cryptography via PhD program at the Graz University of Technology. And that's where I also had most of the founding team of Taceo. Back then we did research in CK, MPC, and FAG. One of more of the notable works in the CK space is from the group is the Poseidon hash function, which, full disclosure, I'm not part of it, but one of the Taceo universities, a designer of the Poseidon hash function. So we knew this space, the CK space, from a rather academic perspective.
Nice. Started from the academia and then you transitioned to the industry.
Exactly. Because around COVID, we got asked from the Austrian government if we could design a protocol that let you combine mobility data with infectious disease data in a privacy-preserving way. We designed a protocol in really a few weeks that combines MPC, FAG, and CK, small parts of MPC, small parts of CK, small parts of FAG, that would allow them to combine this data, who was infected and where they were around the infection. This was a great prototype, and we were really excited about the performance because usually if you talk about these technologies, programmable cryptography in general, mostly the bottlenecks that we see are performance if you deploy it on large scale. And we saw with a very specific protocol and a lot of engineering, we can get to applications that would roll out for nationwide use cases. Unfortunately, it never got deployed. One reason was that we were a research lab and we couldn't really properly follow up from a prototype to a production grade system. And this really bugged us. We saw that we could have real world impact, but we're kind of struck because how we were set up, we cannot follow on. And that's where when the idea in us, we want to do this end to end, and the best way to do is fund the company.
Got it. Yeah, that makes sense. And just curious to hear about the different ways in which ZK, MPC, and also FAG interplay with each other when you were working on that project. So what led you to choose those specific cryptographic primitives?
Yeah, it was really we had kind of requirements. We had two data sources and we had a function that we want to compute. This was given to us. We want to have statistics on this data combined with this data. And then in the end, we try to hide as much information as we can hide possible and started out with MPC and FAG. And at some point we figured out that you could cheat the protocol if you do not have a verification. And that's where we then added some CK that you can verify also the request and make this as a legit request to the protocol and not something malicious who just wants to drain the data.
Got it. And also curious to hear some of your thoughts on the ZK endgame. So there's quite a lot of people in this space who just believe that ZK is just going to be the dominant cryptographic primitive that eventually the school industry will adopt. But curious to hear if you think that's the case, or if we're going to see maybe a combination of these primitives being into play. Right now with visionaries, which is what the Taceo team is really focused on. It's a combination of ZK and MPC. But then also curious to hear if you would see FAG being more dominant in the future. Just wanted to hear more of your general predictions for the prevalence of these primitives.
Yeah. I want to start with the first part of the question where you said kind of that CK is the end for everything what is programming cryptography. I think that's a thesis and that's here that we kind of didn't accept. And 2 years ago at the Science of Blockchain conference, I was wandering around this conference with exactly the question to folks there. Do you think about the limitations of CK and limitations beyond performance and developer experience? And it turned out people didn't thought much about it. But for us, it was really essential that if you do not have some form of confidential compute, regardless of the specific technology we're using, Like you only get half of the job done, the impact we want. Like CK alone is quite limited in the sense that you cannot collaborate on private data. And for us, this seems like essential if we look at the internet and the applications like marketplaces, governance or messaging, all are collaborative and stay for the nature, which CK can't offer. And that's why we started to work on a combination of MPC and CK. And like for FAG, for me, I see FAG as a subset of MPC. So you can look from a high point of view at FAG as like being a two-party MPC protocol. Like it's one of the specific MPC protocols you can deploy for confidential compute. We have different MPC protocols for different parties, for different trust assumptions, and FAG is one of them. For our purposes, especially if you want to combine it with verifiability with CK, which is highly important for the blockchain world, we tend to see that MPC will dominate in the next few years. There could be like an inflection point in a few years. For certain parts of confidential compute, you use an FAG protocol, then go back to an MPC protocol, and like really like this is some of the specifics like infrastructure team will work on, but from the outside, we would really share them up.
Got it. So really the value proposition with combining CK and FPC comes from that collaborative kind of setting that wouldn't really be possible if we were to use just CK alone.
Exactly. Like CK alone gives you a form of private state. Like this is developed and mastered by Nasdaq or like similar chains like Alio or Nivy. But this private state is fragmented by users. And so the minute you want to like do some application that has some collaboration, and collaboration is not an abstract thing, like it's, for example, a private DEX, it is a dark pool, it is a matching algorithm for a dating app. At that point, you would have to open up this private stage to the application, to the operator, and this would like kind of circumvent all the properties that you're searching for at the porting.
Got it. And I'm just curious to hear of any potential limitations that this approach has. Say, is there any kind of increased overhead if you were to combine multiple primitives together, like with CK and MPC? And if there's any ways of addressing that?
Usually, like combining two complex systems or feeds like MPC and CK is like a headache. Like both have overheads today, and quite an overhead, I would say, and combining them can be quite frightening. Thankfully, like against intrusion, we have like seen how to make this rather efficient. Like, so this was the original paper on collaborative snarks from Alex and Dan Bonnet. Like the TLDR of the paper, or like the big insight is if you look at CK computation or if a CK proof generation from a computation perspective, it's mostly linear operations. And the good thing is in MPC systems, linear operations do not occur overhead. So the bulk of the operation that you do, like in a CK proof, isn't affected by any overhead on MSC. Like if you're moving more towards like private shared state, like really collaboratively, like a matching algorithm, there's still some of the stuff like you do heavily need MPC. And of course, here we have an overhead, and which is like currently focus at that zero, like to bring this overhead down.
Got it. So there's different parts where we may see some overhead, but currently the team is working on some optimizations in order to relieve them. Okay, got it. And I was curious to hear more about how the Taceo team is helping to improve the developer experience as well, which is a very a big focus for a lot of CK projects, really trying to help developers making their lives as easy as possible. So for example, we've seen like a lot of different tooling being developed for them, and either different SDKs or even with CK VMs, now developers don't really have to write their own circuits. So I know that Taceo has quite a few different developments, like with co-Circon, Noir. So to my understanding, developers can write their Noir Circon circuits within like an MPC-based environment. So I was wondering if you could talk a little bit more about some of the advantages of that in terms of the types of use cases that these developers can build, and also maybe some of the other types of either tooling or considerations that the team is thinking of when it comes to the developer experience?
Yeah. Like, let me back up a bit, like MPC compared, like you said about CKVMs and domain-specific languages like Nor and Circum, like MPC got like, or like the theory got developed like at the same time than CK in the 1980s. It was like more research, I would say, like more research got into MPC in the first like 10, 20 years. But like then around 2015, when like there was really a lot of funding going into CK for scaling blockchains from May 2018, the tooling got a lot better very fast. And with MPC, we're still stuck at like this academic prototype level. So we don't have any nice programming languages for MPC and so on. So when we set out this journey, we thought like, what would be the nicest way to do MPC? And of course, like we were inspired by like the early tunes like Risk Zero, for example, to doing like the MPC VM. But MPC VM is quite, like even a CK VM is quite tough to engineer, but an MPC VM involves communication as well with other parties. So it's even more complex. And that's why we like refrain from it, because like to keep like it really performant, we looked at the next best option. And there were two options, like doing our own domain-specific language that would be really tailored at MPC. But then we would have the problem, as a lot of projects have, like how do we get adoption? How do we get developers to know this language and so on? So the next best thing was like, hey, we have here a good community of CK developers. They're very educated. They're probably the first one that will use MPC because they're already quite deep into cryptography. If they understand CK, they have no problem of understanding MPC. So let's meet them there. And that's why we started with Circum and co-Circum. Also because like Circum, the language, the feature set is not too large. So it was a good POC for us. And since that POC, we fully focus on Noir, which we believe like we set the standard for a CK domain specific language. And it's like the leading language everybody's converting to if you build anything with CK that has to do with privacy.
Got it. Yeah, it's always really interesting to see kind of the decision-making frameworks that, you know, teams decide to pursue. Like, for example, when the team saw that like implementing an MPC-based VM was not too feasible at the moment, then you looked into developing your own NFTSL.
Yeah.
And then now you see the most appropriate as kind of using existing CKDSLs and allowing users to, place those circuits in those MPC environments. So really great to see kind of the decision-making and process, the whole like the framework behind why co-Circum and co-Noir were developed. So that's all really interesting to hear. Also very curious to hear more about kind of the value propositions behind the idea for a private shared state. So like for a lot of blockchain-based applications, we see a lot of time just public state and then or private state. So just like those two ends of the spectrum. So very curious to hear more about some of the value propositions that kind of shared state, and then some of the opportunities that also arise with this, just on the user perspective.
Yeah. So I think like every time you need private shared, the need for private shared state arises when your application needs private user input and you have to kind of match it or collaborate with it. So if in your business logic, in your app, you're not treating every user individually, but like you kind of do some computation with all the user data together, like a dark pool, like a DeFi, or like a private DEX. Or it's a simple case, like if you want to build a dating app on chain, like how to do the matching. Like I have my private state, you have your private state. How did we match together? Like either we give it to an operator and both they open like our private state, but then we're losing everything on our private data because this operator sees our preferences and yada yada. And so in this case, you need private shared state. You need a way like how you can collaboratively compute if there is a match or not, and only reveal that there is a match and nothing else.
Got it. And just on the topic for these different applications and use cases, even for the dating app, for example, and that you mentioned about governance, about some dexes, about just like any kind of environment where that type of collaboration is needed. Are there any other sort of use cases that are currently being built on Taceo, or any that you are hoping to see be built in the future in terms of those types of applications?
Yeah, I think like very nice frontier are launching games. Like games usually involve a lot of like the real world challenges that we face down the line in a very playful way. And so like every game that has some hidden information state is really like showing off what the potential of the technology is. Like all the sport of war games, for example, or we just had like a workshop on how to shuffle cards without a dealer. Like how do you do like, for example, on-chain poker without having a trusted dealer?
Okay.
Like this boils down to the fact that you need something what we call private shared state.
Got it. Yeah, it's very excited to see all of the how extensive these types of applications are. And also curious to hear more about some of your thoughts, just scoping out a bit on the general industry. Coming from the academic background, I'm wondering if, from when you first got started in the CK space, back when you were in academia, at that time, were there any particular challenges during that time that have now been solved, or any types of new challenges that weren't in place at that time but we're currently now facing? Just very curious to hear about how you have seen the space evolve over the years.
Yeah, I think like from a very like personal point of view, like as the team that I work at the university and also my advisor was like very much focused on the first CK friendly hash functions like Poseidon. I think like there in the last like since like 2018, 19, like there were a lot of progress, and we have like quite decent number of hash functions. So like I see that there is like basically back then there was even like you had to justify in academia why you work on CK friendly hash functions, why this is a thing. This is not completely different. This is completely a complete new research field that is legit on academia. Like this has changed. I saw this, and now I think like the crypto industry gets a bit more like also or like academia and the crypto industry get better along. In CK, like there's more overlap now between researchers in academia and Taceo and actually ones that do some protocols.
Yeah, that's great to hear, because before, ZK has been around for a while, but hasn't been really applied to the industry until like a couple of years ago, right? Back when ZK was the first paper came out back, I believe in the 80s. At that time, everything was just purely Gary. And then we are now beginning to see CK take its initial use cases, at least in the blockchain space. But now, as you say, now there's more collaboration between the academic setting and then also the industry setting. So hopefully we'll see some more like free space of the applications emerge from there.
Yeah, definitely. Like we also seeing like now academia is approaching us again, like because what we are building here, what Aztec is building here, and like all the teams is so cutting edge. Like they are asking like which problems do you want to get solved next, and like also asking about the experience. How is it deploying, and did you face any problems? What is the next trade-off you're looking for? So like it's good like that. Also like there is some interest that really from academia into the industry, looking actively for the problems that are still left to solve.
Yeah, that's really great. A lot of the times I feel like the academia and industry are really misaligned or separate, but it's really great to see them kind of like marrying together.
Yeah, I think like academia just also likes that their papers, their ideas get implemented so fast, like faster than in any other industry. Like you can write a paper and maybe 2 months later, somebody build a library out of it. And like, it's like, wow.
Yeah, it's incredible. Yeah, as you said, can't see this in any other industry. Yeah, and especially how fast-paced this one is as well. It's very exciting. Yeah, amazing. And also wanted to hear more about what's up next for Taceo's roadmap, or any sort of announcements that you'd like to make to any developers, any users in the audience, how they can get more involved.
Yeah. So in a few weeks, we'll start our first production network. And like the first use case will be about private proof delegation. So the product name is Taceo Proof, and it will be for CK protocols and applications that suffer from like bad UX, for which you mount client-side proof and tabs.
Okay.
And like this will be powered by Volkswagen. We'll go live this in a few weeks. And later this summer, we'll upgrade the network to also hold persistent encrypted state. So this will allow long-term application state on the network. So evolving from a CK as a service network to really a more comprehensive encrypted control solution. And like at the end of the year, I will launch like our private jet state solution on the network for large-scale applications. And for developers, like the best way to interact is like through our open source tooling, like Circum and Condor. Like you can build your applications today, like it's all open source. And like once the network is live, like it's also easier to deploy your applications.
Oh, nice. Yeah. So lots of new developments coming up in the next few months and in the next few weeks. Yeah, be on the lookout for that release. So thank you so much, Lukas, for joining me today. And yeah, really great to hear about all of the developments made around in Taceo, and then also really the motivations behind using Cosmars.
Yeah, thank you for the interview.
Yeah, thank you.